Hi everyone, welcome to Library Learning. Today we are tackling an exciting problem involving distribution of products to retail stores. Our goal to minimize the maximum number of products assigned to any single store. Sound challenging? Let's break it down step by step. Here's the problem. We have n retail stores and m product types. Each product type has a certain quantity representing by the array quantities. For example, if quantities are 15, 10, 7, the first product type has 15 items, second has 10, and third has 7. The goal is to distribute all products to the stores while following these rules. A store can receive products of only one type, but any number of them. Second, after distribution, each store will have some products, possibly zero. Third, we want to minimize the maximum number of products any single store receives. Let's call this value x. For example, if n equals to 3 representing stores and quantities which are product types 15, 10, the first product type has 15 items, the second has 10 items. One possible distribution is store 1 gets 10 products of type 1, store 2 gets 5 products of type 1, the store 3 gets 10 products of type 2. Here the maximum number of products any store has is 10. But can we do better? That's the question. This is a classic optimization problem to find the smallest possible x. We can use binary search combined with a validation check. Why binary search? Because x lies between two bounds. The minimum possible value of x is 0 because the store can receive no products. The maximum possible value of x is the largest number in the quantities array, as one store might receive all products of a type. Using binary search, we will find the smallest value of x that satisfied all the conditions. Now let's outline our approach. Perform binary search on the range 0 to maximum quantities. For each midpoint x, check if it's possible to distribute the products such that no store gets more than x products. Adjust the search bounds based on the validation result. To validate if a given x works, we distribute the products greedily to the stores. Start with the first product type and distribute up to x products to each store. Move to the next product type once the current one is fully distributed. If all products are distributed within n stores, then x is valid. Now let's dive into the code. Here's the code for validation. We first write a helper function can distribute. This checks if we can distribute all products such that no store gets more than x products. Here is how it works. J variable starts at 0 to track the first product type. Remaining variable holds the quantity left to distribute for the current product type. For each store, if the store can take all remaining products of the current type, we move to the next type. Otherwise, the store takes X products and we reduce the remaining count. If we run out of stores before distributing all products, we return false. If we exit loop without distributing everything, it means the given x is too small. Next, we implement the main function minimize the maximum, which uses binary search to find the smallest possible x. Here's the code. Left is initialized to 0 because stores can have 0 products. Right is initialized to the largest quantity in the array. We loop through the array to set right to the largest product quantity. The midpoint middle represents potential value of x. If can distribute function returns true, it means we can lower the maximum value, that is right equal middle. Otherwise, we increase the minimum, that is left equal middle plus 1. Finally, left gives the smallest possible x that satisfy all the conditions. Let's see this in action with an example. Input n equals to 3 represents stores. Quantities are 15 and 10 represents product types quantities. Initial bounds are left equals to 0 and right equals to 15. Calculate the midpoint, middle equals 7. Let's check if x equals 7 works for distributing the quantity of each product type to the stores. Starting with the first product type, store 1 gets 7 products of the first type. Remaining quantity of type 1 is 15 subtract by 7 equals 8. Store 2 gets another 7 products of the first type. remaining quantity of type 1 is 8 subtracted by 7 equals to 1. Store 3 gets one product of the first type. Remaining quantity of type 1 is 0. At this point, we have used all stores, but there is still another product type 10 left to distribute. Result, this distribution is not valid because we can't distribute all products with x equals to 7. Since x equals to 7 didn't work, we know we can't use values less than or equals to 7. So update left equal middle plus 1, which is 8. Right remains 15 because we haven't ruled out higher values yet. Calculate the new midpoint. Middle equals to 11. Now let's check if x equals to 11 works. Starting with the first product type, store 1 gets 11 products of the first type. Remaining quantity of type 1 is 15 subtract by 11 equals 4. Store 2 gets the remaining 4 products of the first type. Remaining quantity of type is 0. Move to the second product type. Store 3 gets 10 products of the second type. Remaining quantity of type 2 is 0. At this point, all products have been distributed successfully and no store received more than 11 products. This distribution is valid because all products were distributed with x equals to 11. Since x equals to 11 worked, we know it's possible to distribute with this value or smaller. Update right equals to middle, which is 11. Now calculate the new midpoint again. Middle equals to 9. Now let's check if x equals to 9 works. Starting with the first product type, store 1 gets 9 products of the first type. Remaining quantity of type 1 is 15 subtract by 9 equals 6. Store 2 gets the remaining 6 products of the first type. Remaining quantity of type 1 is 0. Move to the second product type. Store 3 gets 9 products of the second type. Remaining quantity of 2 is 10 subtract by 9, which is 1. At this point, we have used all stores, but there is still another product's quantity 1 which is left to distribute. Result, this distribution is not valid because we can't distribute all products with value 9. Since x equals to 9 didn't work, we know we can't use values less than or equals to 9. So update left equals to mid plus 1, which is 10. And calculate the new midpoint, middle equals to 10. Now let's check if x equals to 10 works. Starting with the first product type, store 1 gets 10 products of the first type. Remaining quantity of type 1 is 15 subtract by 10 equals 5. Store 2 gets the remaining 5 products of the first type. Remaining quantity of type 1 is 0. Move to the second product type. Store 3 gets 10 products of the second type. Remaining quantity of type 2 is 0. At this point, all products have been distributed successfully and no store received more than 10 products. This distribution is valid because all products were distributed with value n. Since x equals to 10 worked, we know it's possible to distribute with this value or smaller. Update right equals to middle, which is 10. Now left equals to right. At that point, left will hold the minimum possible value of x. For this example, the minimized maximum number of products any store receives is 10, and that's how we solve the problem of minimizing the maximum number of products distributed to stores. If you enjoy this explanation, don't forget to like, share and subscribe to Lively Roaring. Love, take care and always keep spreading positivity. Thank you.